In this video, I'm going to briefly go over 4.3 linear regression. I also posted a few videos on just the basics, what you should know about scatter plots and scaling a graph, and also the big picture of what regression analysis is. So make sure you look at those and kind of have an idea about that. Also read your book. Hopefully you already did that. Before we go through this, we're just going to go into some introductory stuff and basics. When you take statistics, you may or may not do this process. We usually do a little bit of it, no matter who you have, but it's just pretty straightforward. You'll use technology. So as long as you have like the idea of what we're doing here and can do some of the number crunching, that's going to be just fine. So we'll start with describing correlation. Number one, you can see there's this little graph that has a bunch of dots on it. And if you kind of looked at those quick, it kind of goes in a straight line. So if we read from left to right for graphs, we are going to look at that as increasing from left to right. And what we do in linear regression is kind of like it's almost like if you were to take like a little ruler there and kind of sit it on its edge, standing up straight up out of the paper, and kind of drop it. It's called a line of best fit. So it's what linear function, there will be only one that really sits the best right in those dots. Now this one is a strong positive correlation. The correlation coefficient R is something that they go over in the overview video. James Sousa does that quite nicely. It's pretty complex. You don't need to know all that, but just R is how close the dots are to this. So if R is closer to -1 or 1, then we have a strong correlation. Okay, if it's closest to 1, it's a positive. So this one is probably pretty close. I'm just gonna kind of just right. R is probably pretty close to 1. Wouldn't be exactly 1. That would be a perfect line. And what I want you to understand is how to write that has a strong positive correlation. Now, if we look to number 2 and we did the same sort of thing and kind of dropped a ruler down, you would not have as many dots touching, and they seem to be more scattered about, right? So that also what we want to notice is that it's going down from left to right. It's descending. So we would say a negative correlation. And it's not that there's no correlation. You can kind of see that there is this trend, but it is not real tight together. So we're going to say that it is a weaker negative correlation. Now number 3 looks like it's just all over the graph. How could if I put a ruler there and dropped it, it could go that way, it could go that way, it could go. There's really no rhyme or reason. So we're going to say for that one that there's no correlation. And R would be probably pretty close to 0. There would be nothing significant. Number 4, what do you guys think for that one? Well, hopefully you said it's a negative linear correlation. and we're looking at linear, so we should probably note that it's linear. And it's pretty tight together, those dots. So we're going to say a strong negative linear correlation. So correlation is when two things kind of go together. It doesn't necessarily mean causation. So correlation, you might have increased ice cream sales in warm weather. Well, maybe the warm weather isn't necessarily, we can't prove that it's causing it, but there's a correlation. When the weather gets warmer, they sell more ice cream and things like that. So we're going to look at a couple of different ways to find the slope-intercept form of an equation of a line that best fits the data. We can use technology. We'll use Desmos momentarily, but first I'll just show you how to do it by hand, because probably a lot of you are going to have that, and we'll see how close we can get. It's going to vary a little bit depending which points you pick, so you want to try to get close. Here's our data set. It's just, these are the same set of data, but there's just two tables to save space. So they just put them side by side rather than continuing down and positioning the graph. That's just how it got laid out. So if we were to just kind of draw a line through there, that one sounds so good, but like, or drop the ruler like I was saying, it would kind of go through like that. So let's see if we can get more precise and figure out an equation. So what if we looked at our data? It's already plotted for us, and we pick a couple of points that I think are pretty close to being on a line. So to do this by hand, we want to first figure out a line. So you can, at home, if you have a straight edge or something that you can stand up and just kind of sit on its edge and drop it down, and then pick a couple of points on that line, like actually draw a line after you drop down your straight edge. I'm going to try to sit one in here for you. Okay, so I stuck that line in there. I think that's my line of best fit. Everybody's would come out pretty different. You might think, oh, you could probably have gotten over more. We're not going to worry too much about that. I am going to show you how to use technology to find this too. In the book, they actually just pick the first point and the last point of the data set and figure it out. Again, these are all estimations. If your line falls a little differently, that's okay. Just pick your couple of points, and then you're gonna pick or figure out your slope and your equation of a line. So I have this one here falls on my line, so I'm going to pick 200, 4,000 as 0.1, and then my other point I'm going to pick 600, 2,500, and you can just find the difference in your y's, the difference in your x's, and divide them. So we're going to do m equals 4,000 minus 2,500 divided by 200 minus 600, and I end up with negative 3.75. So when I go ahead and plug that in, I'm going to plug that in to y equals mx plus b. A little review here. We have 4,000 equals negative 3.75 times 200 plus b. And I end up with, once I crunch the numbers and do the math, I'll get b equals 4,750. I'll let you, crunch your own numbers. So yours might be a little bit different than mine. So it's really an approximation here is what we're talking about. So when I write out my answer, I'm going to write it as y is approximately negative 3.75x plus 4,750. Okay, now if I put these values into Desmos, I'm probably going to get a different answer. If you've done yours, I'm probably going to get a different answer. So let's take a look at that. I'm going to show you Desmos, and if you want to do it along with me, you can pull that up, and we're going to put the data values in. I don't think I can have two screens going for that, so just hopefully you have your video companion sheet. If you don't have it printed out, you might want to jot down the numbers from the table to follow along and try it on your own. Okay, so first thing you want to do is go to desmos.com/calculator, and you can just pull up that free graphing calculator. You don't need an account, but you can make one. We have to hit the plus symbol here to add a table. This is how you would put all the different kinds of things in here. So click table, and then you're going to just write right across. So I'm going to pull up this little tablet. So down in the corner there, you can see my little video recorder thing probably too. So I would have 230, and then I think to tab over, let's see if I can do that. Yeah, tab over using that right arrow, and then put in 4,000. And then let's see if I get another tab. No, I don't want to do that. Oops. I'll fix that. So you actually need to just touch in the next row in that little box. So I get 450, and then tab over to get 3, and then put in 3,000. Oh, I keep hitting the wrong thing. And then 550, tab over, and then 3,000. Tap the box, 720. I'm doing the other row. I'm going to pause this and just fill it in. Okay, so I have my table filled in here. And now to calculate that. Okay, so the next step is we have to hit this plus again and hit expression, that f of x. And we are going to type in y sub 1. So we can just do y1. And then we want to hit the approximation symbol. And so we have to hit that ABC. And then find the little symbol right over here. And then we're going to type in mx1 plus b. And that will give us the regression analysis. So it knows by you plugging that in that it wants a linear regression. We also, I should show the dots on here too. I think I need to make my scale a little bit small, a lot smaller, and make sure those are showing. So I'm going to go a lot smaller. That's why we didn't see them before. So the dots would have been there before, those green dots. That's where this, next to the y sub 1 on the table, if you hold that, you can change your color. You can also make it just connect dot to dot. That's not what we want to do though. We want to make a scatter plot. So we're going to leave it like that. Whoops, I just made it all disappear. Let's get it back. Good. Okay. I'm new at this too. So using this system, I used to use one called Graph, but Desmos has a lot of additional functions. So when we have this data given to us, the statistics is the, we're going to look at the R here. R equals negative 0.9868, so that's a pretty close correlation. We are going to look at the parameters, so our slope is negative 4.2174, and our B is 5044.5. So that's using Desmos. That's what this equation is equivalent to. So when you do this at home and you are given a graph, even if it's in your My Open Math, sometimes you might be able to import stuff. I'm not sure, but you can, or copy and paste it into here. I just type it in. They're pretty short. I tried to choose short ones for you, and then you can just write that as your answer. So I'm going to go back over to the worksheet. In Desmos, we found it to be y equals negative 4.2, I'm just rounding, x plus 5044. Okay, so that's what this line was. So it is pretty close, and you saw what it looked like there. Now number 6, we're gonna, this one looks a little different. It almost looks like a parabola there with this dot on the side, but we're not getting into those yet. We're just gonna say, well, maybe that's an outlier over there. And we would, again, just drop our thing down and see how close that is. I'm gonna look at it in Desmos to see what, I'm just gonna type it in, just like we did the other one. Why don't you stop the video and you can try that, and I'll write the answer up here for you. We'll also work with these in class on Wednesdays, so bring your laptops again. We have some Desmos activities and different things with technology that we'll want to use. And you also are going to have some homework on these, so you want to be able to know how to use the Desmos. We're not quite done with the notes yet, but I'm gonna just give you the answer to this one, let you work on that one, and then I'm gonna make a separate video for the back side of the sheet, and we're gonna just talk about some word problems. Okay, so for number 6, we get y equals 717.66 x plus 303.68. So that is what you should have gotten in Desmos, but if you did do it by hand, then it's going to be just a little bit different. It should be fairly close. Again, just, drop your ruler down and pick a couple of points that fall on that. You could also use a graphing calculator. There's, in the additional videos that I posted for you, there's some demos on that, so you can check that out. Is just put up your lists. You're going to do 2 columns, and it works out really nicely. We use those, or something similar in stats a lot, so have fun with that. And then we'll get on to this next page in the next video.